In this video, we tackle a provocative question: are solar panels the next environmental disaster? While solar energy is often heralded as a key solution to climate change, the hidden costs associated with their production and life cycle reveal a more complex narrative. From the toxic materials used in manufacturing to the environmental impact of mining rare materials, we explore the dark side of solar technology. Join us as we examine the challenges of waste accumulation, energy-intensive processes, and the exploitation of labor within the solar industry. Let's unpack whether the promise of clean energy truly outweighs the potential environmental pitfalls. 1. Toxic materials in production. The manufacture of solar panels involves the use of hazardous materials like cadmium, lead, and silicon tetrachloride. These substances, if not managed correctly, pose significant risks to both human health and the environment. During production, improper handling or accidental spills can lead to contamination of local soil and water sources. Furthermore, at the end of their life cycle, these toxic materials can leach into the ground if the panels are disposed of improperly. This presents a challenge that must be addressed to ensure the sustainability of solar energy as a whole. 2. Energy-intensive manufacturing. Contrary to their clean energy image, the process of manufacturing solar panels is incredibly energy-intensive. Often, the energy required comes from fossil fuels, thereby generating a substantial carbon footprint. This paradoxical situation undermines the very purpose of solar technology, which is to provide a sustainable energy solution. The challenge lies in finding cleaner, more efficient methods of production that don't rely heavily on non-renewable energy sources. 3. Mining of rare materials. The production of solar panels depends on the extraction of rare materials such as quartz and silver. These materials require mining operations that can disrupt ecosystems and consume vast quantities of water. Additionally, the machinery used in these mining processes often runs on fossil fuels, which further contributes to greenhouse gas emissions. The environmental toll of mining raises critical questions about the true sustainability of solar energy. 4. Limited lifespan. Solar panels typically have a lifespan of 25 to 30 years. As more panels reach the end of their life cycle, the issue of disposal becomes increasingly pressing. Millions of decommissioned panels are expected to accumulate, posing a significant waste management challenge. Without proper disposal methods, these panels could become a major environmental concern, contributing to pollution and resource depletion. 5. Lack of recycling infrastructure. Recycling solar panels is not a straightforward process. It is both complex and costly, resulting in many panels ending up in landfills. Here, they pose long-term environmental hazards as toxic materials can seep into the soil and water. The lack of efficient recycling infrastructure is a critical barrier to the sustainable management of solar panel waste, and addressing this issue is crucial for minimizing environmental impact. 6. Waste accumulation crisis. By 2050, the world is projected to face a solar panel waste crisis, with an estimated 78 million metric tons of decommissioned panels. Without effective recycling solutions, this waste could have dire environmental consequences. The accumulation of such vast amounts of waste highlights the urgent need for innovative approaches to recycling and waste management within the solar industry. 7. Supply chain emissions. The global supply chain for solar panels contributes significantly to greenhouse gas emissions. This includes emissions from the transportation of raw materials and finished products. The environmental benefits of solar energy are partially offset by these emissions, emphasizing the need for greener supply chain practices. Reducing emissions throughout the supply chain is essential for maximizing the environmental benefits of solar technology. 8. Exploitation of labor. Ethical concerns have been raised regarding the exploitation of labor within the solar panel supply chain. In developing countries, where labor and environmental standards may be weaker, workers in mining and manufacturing facilities often face poor working conditions. Addressing these ethical issues is vital for ensuring that the solar industry remains a force for good, not only environmentally but socially as well. 9. Environmental cost of solar farms. Large-scale solar farms require significant land areas, which can lead to habitat destruction and loss of biodiversity. The transformation of natural landscapes into solar farms is an often overlooked downside of solar expansion. Balancing the need for renewable energy with the preservation of ecosystems is a critical challenge that must be managed carefully to prevent further environmental degradation. 10. Downcycling instead of recycling. The current recycling methods for solar panels often result in downcycling. This means that materials are repurposed for lower quality applications rather than being reused to create new panels. Downcycling reduces the sustainability of solar technology as it fails to close the loop in the material's life cycle. Developing effective recycling techniques that allow for true recycling, rather than downcycling, is essential for the future of solar energy. Solar panels are undoubtedly a key component in the transition to renewable energy, but their environmental challenges cannot be ignored. The production, disposal, and associated impacts highlight the need for sustainable practices and policies. Balancing the benefits of solar energy with these realities is crucial for a truly sustainable future.